Okay, acids and bases, fundamental concepts, part 2, simple calculations. Okay, last video we talked about the basic concepts of what it meant when I said a solution is acidic, what it meant when I said a solution was basic. It basically meant it basically had to do with the amount of hydrogen ions compared to the amount of hydroxide ions, H plus ions versus OH minus ions. Now we're going to get into some actual math formulas to do some math calculations, and hopefully by discussing those math calculations, get into a little bit better understanding of what's going on with acids and bases. Okay, now when we're talking about simple calculations, the first thing we need to understand is with acids and bases there are 4 different values. There are, with any solution that's either acidic or basic, has 4 different values, and those 4 values are the pH, the pOH, the H plus ion concentration, which would be written like this, H plus with a little bracket, or the OH minus ion concentration. Okay? And the basic skill you need to have and you need to understand is that these 4 values are not independent of each other. They are interrelated. Anytime I affect one of these 4 values, it is going to affect the other 3. Okay? And because these 4, and the other skill you need to be able to have is anytime you know one of these 4 values, you need to be able to use basic formulas to calculate the other 3. And that's the first skill we're going to talk about. Sometimes what they will do is they will give you the pH and they will ask you for the pOH. Okay? Other times they may give you the H plus ion concentration and ask you for the OH minus concentration. Okay? Other times, they may give you the OH minus concentration and ask you for the pH. But the basic concept is, and the basic skill you need to have is anytime you have one of these 4 values, you need to be able to use basic math to come up with the other 3. Now, to do that, we have 3 basic formulas that we're going to talk about right here. And you can see these in any basic chemistry book. You will find these 3 basic equations. pH plus pOH is equal to 14. pH is equal to -1 times the log of the H plus ion concentration, and pOH is equal to -1 times log of the OH minus concentration. Most books won't put the -1 out front. They'll just put, say, negative log of the H plus ion concentration. I put the -1 times out there just to make it really clear and almost idiot-proof to understand what's going on there. But that's the formula. Now, I'm going to throw in 2 additional formulas here that you will not see in your books, but that are helpful. And these 2 formulas are this. And they're really not different formulas. They're just really just rearranging the other formulas. But H plus ion concentration is equal to 1 times 10 to the negative pH, okay? And OH minus concentration is equal to 1 times 10 to the negative pOH. And obviously, if I want to, I can just get rid of that 1 times. Okay? These equations are not different equations, and the reason why most books don't include them is because they're not different equations, even though they are true. They're really just rewriting of the equations that are listed right above them. This equation, pH is equal to -1 times the log of H plus ion concentration. If I use my log rules and I rewrite that in logarithmic form, what I get is I get 1 times 10 to the negative pH, or really just 10 to the negative pH. I throw the 1 times out front there because that's the standard convention that you're going to deal with scientific notation. So these 2 formulas right here, these 2 formulas in red, you're not going to see them in books because they're really just variations of the formulas that are written in blue right above them. All the same, I like to put those in there because students, lots of times, if you're not comfortable with logs, students learn logs in 10th grade Algebra 2, then they forget them, and then years later when they need them in chemistry class, they're all of a sudden a little bit uncomfortable with it. So if you're comfortable with logs, you don't need the 2 equations in red. If you're uncomfortable with the logs, go ahead and put them down there. They'll save you a little bit of time rather than having to have you struggle with logs. Okay, so anyway, let's move on here and let's do some simple calculations. All right, basic chart on the left here, and we have those 3 or 5 equations on the right, depending if you want to count the 2 in red or not. And the basic premise that we have here is, like I said, anytime we are given any one of these 4 values, we need to be able to come up with the other 3. So let's do that, okay? Let's pick a random number. Let's say the number is 6. Let's say the pH is 6. If they give us the pH, can we figure out the other three values? Well, yes, I look at my equation, the first equation at the top of the page, and it tells me the pH plus POH is equal to 8. So if the pH is 6, the POH has to be 8, okay? And the H plus ion concentration is going to have to be 1 times 10 to the negative 6. Because remember, look at this equation, the third equation down, the first one in red. H plus ion concentration is equal to 1 times 10 to the negative pH. Well, if the pH is 6, that means the H plus ion concentration has to be 1 times 10 to the negative 6. Likewise, the OH minus concentration is equal to 1 times 10 to the negative POH. So the the OH minus concentration has to be 1 times 10 to the negative 8. You see how I did that? I started out with just this one, and I was able to figure out the other three, okay? Well, let's do this with another thing. Let's see if we can do that. So obviously pH and POH are pretty easy to work with. If I know one, I know the other. That's really easy. pH plus POH is equal to 7. Is equal to 14. So let's work with something else. Let's say the H plus ion concentration is, say, 1 times 10 to the negative 11th, okay? Well, I do a little work here. I figure out my pH has to be 11, which means my POH has to be 3, which means my OH minus concentration has to be 1 times 10 to the negative 3, okay? You see that? All right, well, if I started with this one, I was able to figure out all three. So that is a basic skill that you need to be able to have, just to do fundamental calculations. Anytime you are given one of these four values, pH, POH, H plus ion concentration, or OH minus concentration, you need to be able to figure out the other three values. But let's work a little bit more with this. Let's try to actually see what it means when I say that these values are all interrelated. Let's say I start with something. Let's say my H plus ion concentration is 7. Well, my pH has to be 7, my PaOH has to be 7, which means my OH minus concentration has to be 1 times 10 to the negative 7. What's significant about this? This and this are equal. And what does that mean? If you remember back from the previous video, when my H plus ion concentration and my OH minus concentration are equal, that means that's the definition of a neutral solution. Okay? And if I somehow increase my H plus ion concentration, that's going to make it acidic. And if I increase my OH minus concentration, that's going to make it basic. But I want you to see what happens when I do something here. Let me show you what happens. Let's say I dump in, okay, and actually let me leave that the same way where it is. That's 1 times 10 to the negative 7. Didn't mean to erase that. Let's say I do something. Let's say I increase my hydrogen ion concentration. Let's say I increase that so that it's 1 times 10 to the negative 4th. What does that do? Well, that's going to change my pH to 4. That's going to change my POH to 10. And that's going to change my POH to 1 times 10 to the negative 10th. So notice what happened here, okay? By increasing my H plus ion concentration, that simultaneously decreased my OH minus concentration, okay? And that is the relationship between H plus ion concentration and OH minus concentration that's really important to understand with acids and bases. That those two values are related, and that they vary inversely, meaning when one goes up, the other goes down. So I ask students sometimes, well, is it possible for both of them to be really high? Can I dump in a lot of H plus and I dump in a lot of OH minus, and so I have really high concentration of H plus and a really high concentration of OH minus? No, that is not possible. If I dump in a lot of a lot of OH minus and a lot of H plus, they're going to bond with each other, form water molecules, and just neutralize. Now in the last video I talked about why it was impossible to have a very low concentration of both, because water naturally dissociates and forms some H plus and some OH minus. So it's impossible for the concentration of both of them to go too low. Likewise, in this video, I want you to hope you think you understand that it's impossible for both of those values, the H plus concentration and the OH minus concentration, it's impossible for both of them to go very high. When one of them goes high, the other automatically goes low. When one of them goes low, the other automatically goes high. That is the really important takeaway of being able to work with these equations.